All right, welcome everyone. I want to thank everyone for joining the first ever tech support hangout for the simulation composite line of Autodesk products. My name is Dean Rose. I'm a product support specialist for simulation composite design as well as simulation composite analysis. Some of you may also recognize me from such products as Simulation Mechanical. For this today's hangout, we're going to be discussing a few topics focused around simulation composite design. We're going to start by covering the upcoming simulation composite design users group. And then moving on from there, we're going to cover the new technology previews available on the Autodesk Labs. And then I'm going to cover one of our great new features available for composite design, and that's going to be reporting functionality. And then at the end of the presentation, we'll open up the floor for some question and answers. The format will be 30 minutes of presentation with 30 minutes of question and answers if anybody has anything. So what is a Hangout? This is probably first time for a few, and some of you may have attended some of the other Hangouts for simulation CFD, mold flow, or mechanical. So just a bit of a refresher. The composite Hangout will be coming about once a month. The point of the Hangouts are just to demystify the whole support process. We've got a lot of great support agents available to answer questions you have. And this is an opportunity to educate users of our product, create an open forum for learning, and empower all of our users. During the Hangouts, we're going to go over some of the popular topics that are encountered by our users and are brought up to support or discussed in the forums. So this is a great opportunity to reach out to everyone. And I hope your coffee's topped off because we've got a lot of exciting information to discover in the next 30 minutes. I'd also recommend all of our listeners to type in questions that you may have into the panel, and we have some people available to go over those, and if we don't have time, we'll cover those at the end. All right, first thing on the agenda, we have an upcoming event for simulation composite design. It's a users group meeting in Denver, Colorado. It's going to be on July 22nd, and it's an all-day event for composite design users to meet up with. Dan Milligan's going to be the host, and you'll also get the opportunity to meet some of the developers and people on our staff that work with composite design. Some of the events going on that day are a demonstration of what's new in Composite Design 2015. They'll also have a Project Cassidy demo. We'll be going over some of that today as well. There's also going to be a Composite Design learning experience, a brief presentation on Support 101 for customers. There will also be a future product enhancement discussion, as well as a 3-hour training course. So there's a link here. You can register online and or visit the site for more information. So jumping into what's new with composite design. We have a thing called Autodesk Labs. I'm not sure if everyone's familiar with that, but I'll go over that. The Labs is our public process for sharing innovative new technologies and collaborative development. The user feedback you provide for the labs is really on ideas while they're still in an early conceptual stage. The process is applied to technology that is commercially relevant to customers in design, whether they're involved in architecture, manufacturing, movies, games, and any other industries. And the best way to learn about Autodesk Labs is to start experimenting yourself, and that's what I'm going to go through today. There's a link here for this Project Cassidy, which is specifically related to composite design. And I'll browse to the site. where this is available. Autodesk Labs has technology previews for many of the different products we're working on specifically for us. You can log in or create an account to get access. And once you get to the home page, you'll see a few things that are available for you. On the upper left-hand corner, there's user forums, project news, and downloads. There's a brief description of what Project Cassidy is. Project Cassidy is a powerful tool used to quickly simulate the bending of a complex laminate part. You also have the ability to import your own part geometry, something a lot of our users have been requesting for some time. And some of the useful results include deflections, failure indices, and safety factors. So once you get here, you can access the download, install. There's also other information pertaining to the product, examples and tutorials. So that's a great resource. I have the program installed on my machine. You open it up, you'll notice it's very similar to the composite design format. And what we'll be looking at specifically is under the simulation 3D surface analysis. It'll open up this panel. You can see here I've been working with a demo material I've used for this Cassidy demonstration. It's just a generic layup to help us walk through and kind of visualize some of the results that we're getting. The motivation for this demo was working on my snowmobile trailer, and there's a cross member that I wanted to see about reinforcing. So I built the geometry in Inventor Fusion. We can go there and go to the area where I've saved it. I've just imported my geometry. It was a stat file and pretty basic, just a channel material or a channel geometry, and it's about 6 inches wide and 36 inches long, fairly flat, something that you'll want to consider when using this tool in your own preview. We're looking for fairly flat parts. Gives the best performance with this tool. And you can see on the screen these blue lines are the material that's going to be draped over our geometry. So we'll just hit the layup button and you can see the visualization of the material being draped over. You can also select this material orientation checkbox and zoom in, and you can see how the material's coordinates are draped over this geometry following all the curves. Then we can go to the bending tab and start to apply our loads and constraints. Right now you can see that we have the part constrained around all the edges. Just to get started, this was a great place to start. I calculated a load from the equipment that I'd have on the trailer to be about 0.77 psi, just a random number that I've kind of calculated. And then I was also concerned about hauling the trailer in the mountains or down a rocky road where it may encounter some impact. So I wanted to simulate a point load where a rock may encounter this. We can edit the load. Here you can see that it's projecting on this surface. Deselect that. I can move this more to the bottom, simulate the lowest point where it may impact something that I'm pulling it over. Once we have our loads applied that we're looking for, we can select apply. This will run through some calculations. and it'll output some basic results. Total deflection. There's some radio buttons over here. You can change from the view that you want. You can select just the part, view your deflections, failure indices, as well as your safety factors. You have this nice manipulation tool here to rotate the views of your part. And you can also view your material orientations while on this screen. You can also show where your concentrated loads are and your fixed constraints. And to show how easy it is to modify some of these things as you're going through with your own preview, you can select edge nodes and select other edge nodes available, or you can unselect edge nodes. So for this, when I envision it going on my trailer, I wouldn't be having it attached at the lower portions of the curved geometry. I would just have these upper surfaces connected. So I want to unselect these. We'll rotate around to the other side, select a few of these on this side. And you can see these edge nodes are available, but they're currently unselected by being grayed out. And then we just hit apply, run through our simulation again, and you can see it didn't have a significant impact on the results. If I wanted to, I could go through and select different edge nodes to simulate a bolted connection or something along those lines. So feel free to check this tool out. It's available for free for a limited time, so I invite everyone to visit the site, download the product, and give us some of your feedback. Some of the areas you can give some feedback are on the user forums. There's a Project Cassidy discussion. We'd love to hear from you on how you're using the product and what you'd like to see. There's also a project news. You can see any updated projects. One of the latest ones is a simulation for a composite manhole cover. So, and then also I was visiting the site today, and it says there's going to be some planned maintenance on the site this evening. So I just wanted to give everybody a warning in case they experience some outage. It wasn't intended, but it just happened to be on the day that I was leading this demo. So, and then next, we're going to go into the composite design program itself. This is the product available to the customers. It's actively supported. The Project Cassidy is not actively supported, so any feedback or questions should be directed to the forum for that. So, moving on to composite design. You can see my screen here. I also wanted to let everyone know this tool is available for free trial, so if you're just looking to discover what's available, get some information about the product, you can visit this website and get some information on what it does, what's available, and use the trial for 30 days. So I invite everyone to do that. And then now we'll go into the reporting feature. Reporting is one of the new features for Composite Design 2015. I'm going to walk through a basic demo, kind of a mock project, and just demonstrate how the reporting feature brings real benefits to the user. So we're going to do a plate analysis. So we'll go up to the plate selection, select plate analysis, and this is going to open up our plate module. And this has everything we need to walk through, from defining the materials to applying geometry and loads. So when the module opens, it opens up on the laminate tab. it will open up your most recently used laminate. So I've been working with this spoolable pipe. You can also select some of the other available laminates that you have stored in your database. For this one, we'll go ahead and use the pre-populated laminate. Here we'll walk through defining just a generic plate. We'll do it rectangular, 10 inches. We'll go 18 inches in length. The thickness you can see is populated from the previous screen from the laminate geometry. And we'll walk through going from tab to tab all the way to the finish. Now we'll want to simulate some bending. There's some pre-populated loading that you can use. For this, we'll just use a uniform pressure load, so the pressure is going to be applied across the entire surface, and then it's going to be simply supported around the edges. So we'll do a 1000 psi, and then we're going to look for getting the maximum deflection at the center of this plate. So we had a 10 by 18 plate, so we'll go ahead and do 5 inches. And for the length, we'll go to 9. And if we have any questions, we can always click back and review what we've previously inputted. Hit calculate, and this gives us our output, all the information we had inputted previously, where we want to get our load, our maximum deflection results, and then it will give us our maximum deflection at that point. And it also gives us some moment information. So now we have all this information and we want to present it to someone. There's a new Add to Report button available. You'll see this in many of the modules, so we'll go ahead and click that. Here it asks us to select a report. This is the first one that we've used, so we don't have any reports existing. We'll create a new one. And here you can see that all our information is going to be populated in this preview. And we'll walk through some of the information that's being input. You see a quick tree here with some selections available. You can deselect to remove or add information. That gives us some of the prepared by, requested by, dates, lists of symbols, kind of a table of contents. We'll walk through. And one of the nice things that's included is the design of Composite, or the version of Composite design that you're using. So if you use this today and you go back 2 years from now, you can see what version you've used as well as all of your inputs, so you can do a really good comparison and make sure you're still getting the results that you want. This goes through all the materials, so we'll starts by outputting the laminate data as well as your laminate layup, and then it'll output some of your ABD and Q-bar data for all your plies that you're using in your material. And then it gets down into your 2-dimensional and 3-dimensional constants that are calculated for that laminate. And then lastly, we get into kind of the meat and potatoes, the actual geometry you're using, the loading, as well as those results we saw outputted earlier. We can also go in and select the General tab, and we can start to modify some of this information. So we can change this report. Add a short description about what the intended goal was or what the analysis was being used for. Change the title, subtitle. You can also change the prepared by. You can add a requested by. I'm going to put my Associate Royce, since he's always telling me what to do. And then you can also add your company information, address, phone number, information that will be used for contacting later down the road. And when you go back to the Results tab, you'll see this information being populated. So it's a really fast way to get all this information out. And then when you want to export it, you have several options available to you here. One of the options I like is HTML. If you have any sort of a SharePoint website that you'd like to share with your team, you can get this output in HTML code. I'll just do a quick demonstration for that here. Go ahead and select a Documents folder or any directory you want, and then save the name. We'll just do hit save. Now we can navigate to this. You can see it's here. It's going to go ahead and open up in your default web browser. And go ahead and open that. And then you can see it's easily viewed through your browser. So it's accessible to a lot of users without having any sort of previous software installed. You can also export to PDF. Same process. I'll go ahead, open this up. And of course, it looks like I must have saved it in another folder. Oh, change the name. Report for demo. Go ahead and click this. And it's going to open up same information as you could see previously, and it also has this section on the left here, so you can quickly jump from section to section. Just a great tool for quickly outputting your results. And then lastly, we have the Word document output. It's the same basis. I don't think we need to go over that right now, but it's available for you as well. And you can close this out by selecting the Close button. It's going to store your data for the session. And then if you'd like to view your report, you go up to the Reporting tab. The available report is already highlighted. We can go in, select Edit, and this is going to bring up all our information that we had previously. And one of the nice things we can see here, say we wanted to go through and do another plate analysis, and we want to change to 8 inches by 18. We had to do a quick modification of the geometry. We're going to keep the load the same. Find that deflection at the center of the plate. Calculate. It's giving us some different results. So we'll go to Add a Report. The report we created previously is available there for selection. Select OK. And now you'll see Plate Analysis and Plate Analysis Study 2. So the information we were using previously still available. And now we have our second plate study. You can see the width and the width has been modified, and the length is the same, and we can see how the results differ. So that's the summary of the reporting functionality. I'd also invite everyone for more information, to visit the help documentation that's now available online. That's new for 2015. And that about covers what we're going over for this What's New in Composite Design 2015 for this Hangout. So I'd like to open up the floor for question and answers.
Hey Dean, this is Royce. Just want to encourage people that have never used the software and maybe have considered using, composites within their products, maybe pose questions about how they might use it for their applications maybe, or how this software might be able to help them out. Maybe we can address some questions like that, since most people here have never really used the product before. So it does make it a little difficult to ask
Sure.
good questions. So let's see if that spurs any thoughts from the crowd.
Sure, I can walk through a quick demonstration of what's available in Composite Design, since I think we do have a lot of users that, or a lot of viewers that have not familiarized themselves with the product. So
Yeah, I think that'd be great.
one of the great things, select new item. We have the ability to create our own fibers, our own matrices, a new lamina from those materials, also core materials, and new laminates. One of the advantages of having the software, it comes pre-populated with some of the more common fibers, matrix materials, as well as a population of various lamina materials. And you can go to the design tree here, select one of the materials, and you get the opportunity to view the elastic modulus, Poisson's ratio, some of the strengths for those materials. So it's really great for a designer that may be looking for a material to use in a design. You don't necessarily need to have all the information immediately. You can use what's available in the library. If you want to create your own fiber, go through, you can input whatever values you find from a data sheet. Just put some arbitrary values in here. You can walk through all the values, and then you can save that material. If you don't have some of the material properties that are required, it'll prompt you, so you can go back and input those values, or we'll not save that. You can open up an existing material and modify this to represent the material you're using if you don't have all the material properties. So we'll do modified, and we'll go in here and we'll change this value to something that we may have seen from a different data sheet. And now we can save. And it's a really quick way to easily create a number of new materials. There's export functionality, so you can export this to an Excel. And then that covers most of the new item creation that's available. You can also go calculate a lot of your laminate properties. Once again, it's going to open up the most recent version or most recent laminate that I've used. You can go through, get some of this output for Q-bar, your various matrices, as well as your 2D and 3D laminate properties. There's also some first ply failure envelopes, as well as a failure envelope, stress, strain, and strength analysis. And then here's where we get into some of the functions that include geometry analysis. So we used this plate analysis earlier in the demonstration. Comes pre-populated with some width and length. You input those values. You can do a bending simulation, stability, or a vibration analysis. Can move on to the sandwich analysis, very similar. You'll see on the geometry there's some different information available. You can define the thickness of your core material. You can also define the core material that you'd like to use, as well as the laminates that you're using in the surface of that sandwich panel. Same thing, you define the width and the length, core thickness, face thickness is pre-populated, and then you can go through some of the same simulations. This one, for example, has some of the different loading scenarios available, and it gives you a nice visual representation of what's going on when you're loading that selection. So lots of graphical representations, panel bending, and then also a stability module. I'll continue on. Tube beam is very popular. A lot of people do analyses using this. You can see here it gives you available selections for various geometry cross sections: rectangle, plate, circle, so on and so forth, eye section, cross sections, and you can define these just by using the visual information there. And then you can walk through, and some of these same boundary conditions are available. And there's also a pressure vessel, so if you're doing some sort of a pressure vessel design, you can also do an analysis for that. And then we have lots of great utilities available. One of the other new features for Composite Design 2015 is the spring-in calculator. There's also the ability to export these materials you're creating within Composite Design to other FEA packages. So this is kind of a standalone tool for doing simple structural analyses. But if you'd like to do finite element analysis, you have the option of exporting this material data into Abacus or ANSYS, Nastran, also simulation mechanical. So you can select the material. We'll do the one that we modified. Oh, this is for lamina, so we don't. That was a fiber we modified, so we'll go ahead and use this 3501-6. Can show your output, and it outputs in the format that's being read by the FEA package that you're desiring. So you can scroll through and actually see what the output is. So that's a great feature that's relatively new. And then lastly, the reporting. So a lot of great things for doing simple structural analyses using composite materials. Did we have any other questions?
Yes, we did. There was a question that came in. Can you go through the failure criteria and which ones are available? First
Sure.
ply failure, primary, etc. And to go along with that, can you go through the failure? Oh, I guess that's a repeat. Is it possible to change the local coordinates? For example, let's say I have a laminate that has additional lamina on the corners.
We'll start by going through the failure criterion that are available.
Okay.
And then we'll go into the second part of that question. So again, we have our laminate. We'll apply just an axial load. We can view the stresses in global or local coordinate systems, stresses and strains. We can select our location, top, middle, or bottom of the ply. We also have the option to plot some of this information to give us a visual representation. We have the option to modify some of that. We can capture mid-plane strains. And then once we get to our first ply failure, you can see we have a drop-down here for available failure criterion. Default is max stress, but we also have max strain, Sci-Wu, Sci-Hill, Hasheen, Christensen, Puck, and MCT. Some of these require additional inputs. So if you're going to use the Sci-Wu, you'll see this become highlighted, and you'll have to input the F-star parameter. A lot of this is covered in the help. The help can be accessed through the help menu. We can go here so everyone can see. Go through new user quick start guide. And I'm looking here. Expand this out, and we can see some information pertaining to what we'll be looking for as far as failure criterion. Right here it says select one of the 7 available criterion. We can go to the appendix, and it gives a definition of all the failure criterion that are available. Select max strain, and it goes through some information behind that on what's going on. So that's a great resource for the user. We'll go ahead and select max stress. So this will give us our first ply failure, indicates what ply, and the failure index for that ply, as well as the safety factor. And then we can continue to a progressive failure scenario. So we have our 20 ply laminate, and we're going to do a progressive failure analysis. It runs through, does a load increment with 200 increments. A lot of these parameters can be modified. And you can scroll down and go through, and you can see with this loading that we're using, it's not indicating any sort of failure. If you want to quickly view that, you can remove the non-failed plies, which in this case will remove everything. You can also add this to the report or select plot. We can bump this up, see if we get some failure. So right here in this first load increment, we can see that some information about the state of stress, and then we can also see the failed plies. It lists out each ply that's been failed. So in this case, all 20 plies have failed, as well as the failure modes for each ply. And you can change the stress criterion, or the failure criterion, run another calculation, and see how that impacts your results. And then I believe the second part to that question was how to view in the local coordinate system.
Is it possible to change local coordinates? For example, let's say I have a laminate that has additional lamina on the corners, if that makes sense.
On the corners? I believe the scenarios you'd use for this would just be kind of a equally distributed laminate. So you wouldn't have any additional buildup on the corners. This is not a tool that's going to be able to consider that. But Mike, do you have any input on that?
Well,
Is
Mike,
Mike available?
yeah, it doesn't seem like he's available, but person that asked that question earlier said, more specifically, can I simulate a non-uniform cross-section? Let's say I've added laminate on the corners, stiffen them up, and I think based on what Dean said, it's more of a continuous sheet of composite material.
Yeah, you'd be looking for the uniform cross-section, so
Yeah.
there may be a way to get around that, but just out of the box, that's not something that I believe composite design can do. But if you want, we can push that one to the user forum for composite design, and we can post that question on there and get some more eyes on it and see if there's something that we could do.
Dean, is that something you can do in composite analysis? Non-uniform
Composite
cross-sections?
analysis is another analysis tool for composites. It's an add-on package for FEA tools like Abacus, ANSYS, and MSD Nastran. And you would be able to do an analysis for something like that. So if they're using an FEA package like that, then composite analysis is a much more advanced tool that's capable of solving those type of problems.
Okay, Dean, that's all the questions we have this time, so you can wrap up the webinar.
Okay, great. Well, I want to thank everybody for attending, and if anybody has any ideas for future Hangout discussions, I'd be happy to hear from you on the forums or via the support methods that we have, and we'll get some great discussions for things our customers are using and things people want to see. So we'll hang out for a few more minutes, and if anybody has anything, feel free to chime in.
Josh Taylor did have one more question to go back to the local coordinate manipulation. He said, let's say I vary the lamina by laying up individual pieces by hand. Is that possible to simulate?
I'm not sure. So you're able to define the angle of your lamina. So if you have different angles, I'm not sure if he's changing the orientation of that ply somewhere in the cross section, like a change in geometry or something like that. That that wouldn't be something that this tool would be used for, if I'm understanding the question correctly.
Okay. So this time, I think if there's any more questions, we will have composites hangouts going on every month moving forward. But if you have any other questions, I'd encourage you to continue the conversation in the forums. So this time, we will end the hangout, and we look forward to talking to you in 4 weeks. Thank you.